This is your first class in thermochemistry. This is probably my 5th time trying to take this video. Hopefully it works this time. I am going to speak quickly because I have to pick up my boys to go swimming. So if I'm going too fast, please press pause so you can get the notes. So you should be ready to take notes now. So thermochemistry is the study of energy changes during physical or chemical changes in matter, and it's called thermochemistry. So thermochemistry is part of our everyday. Combustion engines and cars use thermal energy when it's really cold in February. Our power grid can be overused, and the power from Muskrat Falls is not enough. So then they engage Holyrood Power Station, and at Holyrood Power Station, they actually burn crude oil to heat St. John's and surrounding areas. So we actually use thermochemistry often in our everyday lives. So energy is pretty hard for scientists to actually define, but energy is defined as the ability to do work. This in thermochemistry, it's going to be or produce heat. So we don't talk about energy very often as to do work. It's going to be in this course, energy to produce heat. So work is the application of a force that is associated with the movement of an object over a specific distance. That's usually studied in physics. And both energy and work are measured in joules. You can have thermal energy, which we'll be talking about mainly in this unit. Nuclear energy is another type. Chemical energy, we will be talking about when chemical reactions occur and they're exothermic or endothermic. Kinetic energy, the energy of movement, and then potential energy, and that's your energy that is stored. So all forms of energy can be classified as either kinetic energy or potential energy. Potential energy is energy due to the position or composition of an object. It's a stored energy, and for your course, you need to know that the potential energy is stored in bonds. Kinetic energy, on the other hand, is the energy of movement or motion. It results from the movement of particles. So kinetic means movement. So the total quantity of potential and kinetic energy associated with the motion of particles in a substance is called thermal energy. The quantity of thermal energy of a substance depends on how fast its particles are moving. So to this point, solids have only so much energy. So they have the least amount of energy. Then it's liquids. Then it's gas. So your solids are just really vibrating in place, the molecules. Liquids can flow over one another, and then gas is all over the place, completely random. So this is amount of energy. And that concept will come up later, this unit. So temperature versus heat. Temperature is the measure of average kinetic energy. So this is your definition right here. Of the particles in a system. So as a substance is warmed, its particles move faster, giving them a greater kinetic energy and increasing the temperature of the substance. Now, as the substance is cooled, its particles move slower, giving them lower kinetic energy and decreasing the temperature of the substance. Heat is defined as the transfer or movement of thermal energy from a warmer object to a cooler object. And the heat is energy which transferred as a result of a temperature difference. So in this object right here, the warmer object would transfer its heat to the, in this example right here, the warmer object would transfer its heat to the cooler object. The last definition I need you to know for the next 2 pages is thermal energy. And thermal energy is the total energy of all particles. Cool. If you aren't done, pause and get your notes and then press play again. Temperature versus heat. So this page explains that idea of heat transfers. So heat flows from matter with higher average kinetic energy or higher temperature to matter with lower average kinetic energy or lower temperature. So a really good example of this, sitting in your desk, you can touch the metal on your desk. Your hand should be quite warm in comparison to that metal on your desk, and instantly a heat transfer will occur. So heat will be flowing from your hand to the cool desk, and eventually you'll find the desk not as cold as it was. And that's because eventually your hand and the desk will be the same temperature. So when two samples are in thermal contact, that means touching, energy transfer will occur until thermal equilibrium is achieved. So thermal contact means touching, and thermal equilibrium achieved means same temperature. So if as you are touching the metal on your desk, your hand will go down in temperature, your desk will go up in temperature, and they will eventually be at thermal equilibrium, which is the same temperature. So you can see that explained in this diagram as well. So now we're getting into the test yourself questions. We have two bundles of copper wire having the same masses but different temperatures. So what can you say about average kinetic energy of the copper atoms in each bundle? So the higher temperature bundle will have higher average KE, that means kinetic energy. The lower temperature has lower average kinetic energy. So what happens if they are in contact with each other? Heat flows from warmer wire to colder wire until thermal equilibrium is reached, and that means once they are the same temperature. Thermal equilibrium is when objects are the same temperature. So what would happen if two bundles had the same temperature? So same temperature means that they have the same kinetic energy. So I'm going to write down same temperature, or TMP, equals same KE, kinetic energy. So no heat transfer. Now, the last question here. Two bundles of copper wire have different masses but the same temperature. What can you say about the average kinetic energy of the copper atoms in each bundle? So, same temperature equals same average KE, kinetic energy. The larger mass will have more energy since it has more mass. So because one bundle is bigger, it will have more energy because it has more mass. But when it comes down to average kinetic energy, because they're the same temperature, they are the same average kinetic energy. Perfect. If you don't have it all written down, press pause on the video. So worksheet number 1 is what you're going to do today. What is the definition of temperature? So that can be found on the front page. What is the definition of heat? That can be found on the front page. Definition of kinetic energy, front page. What is the definition of chemical potential energy? So front page again. Which type of energy is associated with a change in temperature of a substance? So that's just a one-word answer there for number 5. Number 6 is also just a one-word answer. So which type of energy is associated with a change in the state of a substance? What is the unit of the energy? So that would be joules. And does an instrument exist that can measure it? No. So to calculate energies, we need to calculate things like mass specific heat capacity, temperature, and convert it into joules. Number 8 has blocks A and B are in thermal contact, and it's asking you which way does the heat flow. The second question is how long will energy be transferred? So make sure when you're answering that question, thermal equilibrium is in your answer. Sorry I had to go so fast, but fifth time I am getting impatient. Thank you so much, guys. Have a great day.